Today we will discuss about the mathematics behind this particular growth pattern. So what we are going to study? We are going to study about how to calculate the growth rate. And this growth rate contribute to the basic physiological and ecological research, and it also gives the solution to applied problems in industry. In industry we know that microorganisms are used for production of several metabolites, and therefore they require large fermenters, and in these fermenters microorganisms should grow at optimum conditions. So they determine the growth rate, means how what is the growth rate at different conditions. So growth rate is very important, and during the exponential phase each microorganism divide at a constant interval. Each microorganism divide at a constant interval. Now, divide means what? The bacteria, we know that they multiply by binary fission. So, one bacterium divides to give two daughter cells. Okay, and then these two daughter cells they increase in size, and they again divide to give four total four daughter cells. Okay, so this is one generation, and this is second generation. So after one generation, one cell gives two daughter cells. After two generation, from one cell we get four daughter cells. Okay, thus the population will double in number during a specific length of time, and this time is called as generation time or doubling time. Generation time or doubling time. Okay, so today our discussion will be focused on this generation time and or doubling time. So during exponential phase, what happens? Each microorganism is dividing at constant interval, and thus the population will double in number. The population will double in number uh, during that particular doubling time. So this situation can be illustrated by a simple example. Suppose there is a culture which is inoculated with one cell. Is inoculated with one cell. There is a culture which is inoculated with one cell. Let me just check who has come in the lobby. Okay, and this cell divides after every 20 minutes. This cell will divide after every 20 minutes. So at the end of 20 minutes there will be two cells. Again at the end of 20 minutes there will be four cells, and therefore after 40 minutes there will be total four cells present in that particular medium, because the population is doubling every 20 minutes. Population is doubling after every 20 minutes, and the increase in population is always 2 raised to n. Increase in population is always 2 raised to n, where the n is number of generation. N is number of generations. Okay, so more the number of generation, more will be the population. Suppose there are 8 generations, so 2 raised to 8, that will be the number of population after the 8 generation. So we can simply write it in tabular form also. Suppose we are writing it in tabular form. The first column is minute, then the division number. Okay, the corresponding value for 2 raised to n. So suppose time is 0 minute, so division will be 0. Therefore, 2 raised to 0, which is equal to 1. So at 0 time, there is only one cell. Now, after 20 minutes, the division will be 1. So the 2 raised to n is equal to 2 raised to 1, which is equal to 2. After 40 minutes, division will be 2. So 2 raised to 2 will be 4. So total number of cells or the population will be 4. After say 60 minutes, division will be 3. So 2 raised to 3, that is 8. Then 80 minutes, 4. 2 raised to 4, which is equal to 16. And then you can just go on increasing. 2 raised to 5, which is 32, and after 120 minutes, that is after 2 hours, 6 generations will happen. So the population will be 64, and this population can also be calculated as the population is equal to 2 uh, initial number of bacteria, that is n0. N0 is initial number of bacteria multiplied by 2 raised to n. Now initial number of bacterium is 1. So and we have calculated 2 raised to n is equal to 1. So it will be 1. 1 into 1 is 1. Then 2 into 1 is 2. 1 into 4 is 4, 8, 16, and so on. 32 and 64. So this is how the bacteria shows the increase in their number with respect to time, and this increase is also a logarithmic increase. Okay, logarithmic increase means what? There is an exponential increase in the number of bacteria. So if you plot a graph of the incubation time versus the just trying to be precise. So if you plot a graph of incubation time versus the number of cells, so you will get as for these 6 points, ये जो हमने 6 points निकाले हैं, okay, on x-axis we have the incubation time in minutes. So incubation time, for example, it is 20 minutes, then 40 minutes, then 60 minutes, and then 80 minutes, 100 minutes, and 120 minutes. So initially we had only one cell, and okay, after 20 minutes we got two cells. Then after 40 minutes we got four cells. Then after 60 minutes we got 8 cells. Then we got some 16 cells, then we got 32 cells, and then we got these 64 cells. So if you see the line, this is a curve line. Okay, this type of line we will get. It is a smooth curve. Now I could not draw that smooth curve. So this type of line we will get. But if you take the log of these cells, if you take the log of this number of bacteria, then you will get figures like this. For the 1, it is 0.00. Log of 2 is 0.301. Log of 4 is 0.602. 0.903. Very easy to remember. 1.204, 1.505, 1.806. Okay, so these numbers you will get for the log, and if you plot it on this graph, please this will appear like 1, 2, 3, 4, 5. So here you will get a straight line graph. For log number, you will get a straight line graph. Okay, so this straight line graph represents the log number of cells with increasing time. Now come to this some of the mathematics. So these observations can be expressed as equation for generation time. So first of all, we will assume that n0 is equal to initial population. Initial population. आपको समझ में आ रहा है ना ये?
सर वो लॉग नंबर
लॉग का क्या?
सर वो लॉग नंबर नहीं समझा।
लॉग एक्चुअली ना, लॉग के लिए आपको एक लॉग बुक रहता है, ठीक है, और कैलकुलेटर में भी आपके लॉग रहता है. सो इफ यू जस्ट टाइप log of 1, you will get the value as 0. log of 1 is 0 and log of 10 is 1. ठीक है, तो वो उसका एक सिस्टम है, तो आई कैन टीच यू दैट बिकॉज दैट्स नॉट माय एरिया ऑफ एक्सपर्टाइज. लेकिन कुछ वैल्यूज है जो फिक्स रहते हैं, तो जो हम याद कर सकते हैं. जैसे फॉर log of 2 is the 0.301. okay, log of 4 is just multiplied by 2, so you will get the value 603, 0.602. log of 8, तो आपको जस्ट इसे आपको ऐड करना है ये दोनों वैल्यूज को, 4 एंड 6 को. सो यू विल गेट द वैल्यू एज 903. फिर log of 16, तो उसमें इसमें आपको log of 8 एंड log of 2 दोनों अगर आपने ऐड कर दिए, यू विल गेट द वैल्यू फॉर log of 16. और log of 32 के लिए log of 16 प्लस log of 2 अगर कर दिए तो आपको वैल्यू मिल जाएगी 1.505. log of 64 के लिए भी log of 32 प्लस log of 2, इसे आपने कर दिया एडिशन, तो यू विल गेट 1.806. तो ये वैल्यूज उसकी मिलती है. और अदरवाइज यू कैन यूज द लॉग टेबल, यू कैन यूज द कैलकुलेटर टू फाइंड आउट द लॉग वैल्यू. और अगर आप लॉग वैल्यू प्लॉट करते हो ना, यू गेट द स्ट्रेट लाइन ग्राफ फॉर द नंबर ऑफ बैक्टीरिया. जैसे कि अभी कोविड के केसेस लास्ट ईयर बहुत बढ़ रहे थे, तो सो वी यूज टू गेट टू टाइप्स ऑफ ग्राफ. ऐसा एक कर्व आता था, और एक स्ट्रेट लाइन आता था. स्ट्रेट लाइन जो है दैट इज द लॉग नंबर, और कर्व जो है वो दैट इज द number of bacteria. In that case it was number of patients. So many times क्या होता था ना, ये कर्व जो रहता है being a smooth curve, तो लोग बोलते थे कि नहीं अभी वो स्लो हो रहा है, बट इट इज नॉट स्लोइंग, इट इज गोइंग विद द सेम स्पेस. क्योंकि अगर उसका लॉग आपने निकाला और वैल्यूज प्लॉट किए, यू विल गेट स्ट्रेट लाइन, सो इट इज इंक्रीजिंग. तो यहाँ पर भी क्या होता है कि बैक्टीरिया का नंबर बहुत ज्यादा रहता है. जो सस्पेंशन हम बनाते हैं, थिक सस्पेंशन अगर हमने बनाया, सो नंबर ऑफ बैक्टीरिया इज 10⁷ to 10⁸. तो 10⁷ अगर बोले आप, तो इट इज अबाउट 1 करोड़. तो 1 करोड़ तो हम यहाँ पे प्लॉट नहीं कर सकते ना, इतना इतना जीरो. सो व्हाट वी जनरली डू, वी use the log values. So instead of writing 1 crore, what we write 1 into 10⁷. फिर 1 करोड़ का 2 करोड़ हो गया, तो हमें वहां पे 2 करोड़ इतना स्केल बढ़ाने की जरूरत नहीं. वी कैन जस्ट राइट 2 into 10⁷. 3 करोड़ के लिए 3 into 10⁷. तो इस तरह से हम बाय यूजिंग द लॉग वी कैन मिनिमाइज द स्केल एंड वी कैन प्लॉट अ ग्राफ. ठीक है, सो
ओके सर.
So now let's assume that the initial population is 0. Remember, we are interested in finding the generation time or the growth rate or the doubling time. So initial population is 0. यानी जितना आप inoculate कर रहे हो n0, it may be 1 bacterium, 10 bacterium, whatever it is. ठीक है. Now what we have to consider another factor that is the time of the incubation. So NT, sorry, total population. NT is the population at time T. Population after the incubation of time T. Population at time T. And the small n is equal to number of generations. Number of generations in time t. Okay, so the formula for the population at time t, it is equal to nt is equal to n0 into 2 raised to n. nt is what? Total population. So ये जो total population है यहाँ पर, this 64, this is total population, and this total population is n0 into 2 raised to n. बराबर. So we have a formula for the total population. Total population is equal to n0 into 10 raised to, sorry, 2 raised to n, where n is total population, n0 is the initial number of bacteria or cells which were inoculated in the broth, and this n is the total number of generations. Okay. Now we will solve this by applying the log. So we will solve it by applying the log to the base 10. So if you apply log to this equation, it will be log of nt is equal to log of n0. अभी ये जो माइनस मल्टीप्लीकेशन है वो अगर हमने log अप्लाई किया तो वो प्लस हो जाएगा. So plus log of 2 raised to n. So whenever there is this log of there is raised to in some number, that raised to number comes as a multiplication factor. So it is equal to log of n0 plus 2, sorry, n log of 2. ये जो ऊपर वाला n है वो यहाँ आ जाएगा, n into log of 2. Okay, and now we can solve this equation for getting the n. N is the generation time. We are interested in this generation time. So how we can solve it? So n is equal to log of nt. अब ये जो प्लस है यहाँ पर, तो इस साइड में आएगा तो वो माइनस हो जाएगा, माइनस log of n0, और ये जो log 2 यहाँ पर मल्टीप्लीकेशन कर रहा था वो इधर आएगा तो डिवीजन करेगा, डिवाइडेड बाय log of 2. ओके, यहाँ तक समझ में आया आपको? We have just applied the logarithm to the equation that we got. The equation was nt is equal to n0 into 2 raised to n. तो ये जो इक्वेशन है इसे हमने log अप्लाई कर दिया. So applying log to both the sides, what we got? Log of nt is equal to log of n0 plus log of 2 raised to n. तो उसे सिंप्लीफाई कर दिया. फिर log of nt is equal to log of n0 plus 2, sorry, n log of 2. And then we solve this equation for n. So n is equal to log of nt. तो ये log of nt यहाँ पर है already. So what we did, we just solve this equation for the n. हमें n का वैल्यू चाहिए, तो ये जो n0 यहाँ पे प्लस है वो राइट लेफ्ट हैंड साइड में जाएगा तो माइनस हो जाएगा. सो log of nt माइनस log of n0, और यहाँ पर log 2 मल्टीप्लाई कर रहा है तो वो लेफ्ट साइड में जाएगा तो डिवाइड करेगा. सो डिवाइडेड बाय log of 2. सो दिस इज इक्वल टू n is equal to log of nt minus log of n0 divided by log of 2 का वैल्यू 0.301. ठीक है, so this is the equation for calculating the generation time, where nt is the total number of cell after incubation time and n0 is the initial number of bacteria. ठीक है, so we can also find out the growth rate constant or mean growth rate constant. Mean growth rate constant. Okay, so the rate of growth during the exponential phase in a batch culture means there are different types of culture, batch and continuous. So the growth curve that we get is in the batch culture. So the rate of growth during the exponential phase in a batch culture can be expressed in terms of this mean growth constant, which is denoted as k. It is denoted as k, and this is actually the number of generation per unit time. This k is nothing but the number of generations. Number of generations हम कैसे denote करते हैं? By this n, number of generation divided by t. T is the time. So this mean growth rate constant is the number of generation per unit time, and it is always expressed as generation per hour. Generations per hour. So k is equal to n upon t. Now we have the equation for n. We just derived that equation for n. So this is the equation for n. Now what we will do, we will substitute this equation for n into the equation for mean growth rate constant, that is for k. So now our equation will become k is equal to, instead of this n, okay, somebody is there in the waiting. So k is equal to, now instead of n, we will write that equation for the n, which is log of nt minus log of n0 divided by okay. So uh, we have substituted the value of n, and now we have to write this t over here. So now it is completing the equation for mean growth rate constant. So mean growth rate constant k, which is also known as generations per hour, is equal to log of nt minus log of n0 divided by 3 point, sorry, 0.301 into t. Okay, so have you understood this generations per hour or mean growth rate constant?
Yes, sir.
Okay.
Please repeat, sir.
See, first we derived the equation for the number of generation, that is small n. Number of generation is equal to log of nt, that is the log of total number of cells after incubation time t, minus log of n0, that is the initial number of cells, divided by 0.301. And thereafter we derive the equation for mean growth rate constant. So this mean growth rate constant is always represented as the number of generations per hour. So number of generations हम कैसे denote करते हैं? By small n. or time unit time, we can represent it as t. So the equation for k is n divided by t. तो इसमें सिर्फ हमने n के जो वैल्यूज है वो सब्सटीट्यूट किए. वी हैव सब्सटीट्यूटेड दिस वैल्यू ऑफ n ओवर हियर एंड दैट वैल्यू इज log of nt minus log of n0 divided by 0.301. और ये जो इनिशियल t है इसके फॉर्मूला में ऑलरेडी वो हमने यहाँ पर शिफ्ट कर दिया. सो हियर वी गॉट द इक्वेशन फॉर k which is the mean growth rate constant. Now uh, now we will move on to the generation time. तो generation time में क्या होता है, that cells double in number. So we will calculate the mean generation time. So mean generation time is the time that a population takes to double in size is known as the mean generation time. So mean generation time is nothing but a doubling time which can be denoted as G. It is the generation time, G for generation time. So suppose that if a population requires a time equal to t for doubling, then it's the time is its generation time. So doubling means what? जो nt का वैल्यू है, nt is what? Total number of cells after incubation time t. तो अगर if t is the generation time, then this nt value will be double of the initial number of bacteria, that is n0. nt will be equal to 2 into n0. तो यानी अगर doubling time, say for example doubling time is 20 minutes. Okay, so after, and suppose the initial number of cells that you have inoculated is 100 cells, यानी n0 आपने inoculate किए. So after 20 minutes this total number of cells after 20 minutes will be 200. बराबर. So this 2 into n0 is equal to 200. So the equation is the nt is equal to 2 into n0. Or now we can substitute this 2 into n0 into the mean growth rate equation and solve that equation for the value of k. तो पहले हमने कौन सा इक्वेशन डिराइव किया था? this k is equal to log of nt minus log of n0 divided by 0.301 into t. अभी इसमें हमें ये nt का वैल्यू सब्स्टिट्यूट करना है. nt, this value we have to substitute into this equation. तो यहाँ पर nt का वैल्यू कितना है? 2 into n0. ओके, तो सिर्फ हम वो वैल्यू सब्स्टिट्यूट करेंगे. सो k is equal to log of, instead of writing nt we will write 2n0 minus log of n0 divided by 0.301 into t है ना, but we have here derived the t is equal to g, that is generation time. So we will write g. ठीक है. So now the new equation is k is equal to log of 2 into n0 minus n0 minus log of n0 divided by 0.301 g. ओके.
सर टी डिवाइड मध्ये होता ना?
टी, हाँ, तिथे इंस्टेड ऑफ टी वी आर राइटिंग जी नाउ, बिकॉज यहाँ पर हमने देखा ना, इफ टी इज द जनरेशन टाइम, सो वी हैव रिटन इट एज जी. इंस्टेड ऑफ टी वी आर राइटिंग जी. समझते हैं? एनी डाउट?
रिपीट करा ना इक्वेशन.
ओके, सी the mean generation time, we are discussing about generation time. What is generation time? The time required to double the number of cell is known as generation time. Okay, and generation time never remains constant. So as the cells grow, the time passes, the generation time also changes. So instead of considering only one generation time, the mean generation time is considered. Now this is just an example. So suppose the t is equal to the generation time, that is generation time is the time required to double the cells. Okay, or after time t, the number of bacteria will be nt, that is total number of bacteria after incubation. Okay, so it will be nt, and if the initial number of bacteria is n0, so after incubation time t, it will be doubled. It will become nt. So nt is equal to 2 into n0. ये समझ में आया आपको?
Yes, sir.
Okay, so now we have two different things. One is t is equal to g and nt is equal to 2n0. Barabar? Now we just have to substitute this value into the first equation. तो यहाँ पर equation में क्या लिखा है? Log of nt. Instead of writing nt, we will write 2 into n0. 2 into n0. ठीक है? And here, since t is equal to g, instead of writing this t, we will write g. Okay, that is the equations. तो यही इक्वेशन यहाँ पर लिखा है, log of 2 into n0 minus log of n0 divided by 0.301 into g. And now we will solve this for k. So log of 2 into n0 is equal to log of 2 plus log of n0 minus log of n0. ठीक है, divided by 0.301 g. अब यहाँ पर this plus log n0 minus log n0 will get cancelled. Now what remain is log of 2. Log of 2 कितना रहता है? It is
0.301.
0.301 divided by 0.301 g. तो ये 0.301 ये भी कैंसिल हो जाएंगे, तो बचा क्या? सो k इज इक्वल टू 1 अपॉन g. k इज इक्वल टू 1 अपॉन g. So what is the meaning of this? The mean generation time is reciprocal to mean growth rate constant. Okay, this k is growth rate constant. So growth rate constant is reciprocal to generation time. It is indirectly proportional to the generation time, or reciprocal, not proportional. We will write it as it is reciprocal to generation time. G is the generation time. ठीक है, चलो. So we have the formula now. K is equal to 1 upon g, which gives us relationship between the growth rate constant and generation time. We have a formula for the calculating the growth rate constant. So if we know the final number of cell and initial number of cell and the generation time, we can find the growth rate constant. We can also use this first formula. तो यहाँ पर जो first था, इधर हमने NT लिखा. So we can also use this formula. ठीक है, चलो. I will give you one question. तो आप उसे solve करने की कोशिश करो. The question is, a bacterial population increases. A bacterial population increases from 10 raised to 3 to 10 raised to 9 cells in 10 hours. Bacterial cells increases from 10 raised to 3 cells to 10 raised to 9 cells in 10 hours. So what is the generation time? करोगे आप, अटेम्प्ट करोगे? This n0 is equal to 10 raised to 3, nt is equal to 10 raised to 9 and t is equal to 10 hours. चलो ये मैंने आपको बता दिया. Now you have to apply a proper equation to get the generation time. First of all, find out how many generations has taken place and then find out the generation time. 1 hour में कितने generations होते हैं, then find out how many generations, what is the generation time. करोगे आप solve? अभी करोगे?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, now do it. So what is your value for k?
19.9.
नहीं, log of nt is 10 raised to 9 minus log of 10 raised to 3 divided by 0.301 into 10 hours. Okay, तो log of 10 raised to 9 is 9, क्योंकि वो कैसे लिखा जाता है, 9 into log of 10 minus 3 into log of 3 divided by 0.301 into 10. Okay, now log of 10 का वैल्यू है 1, so 9 into 1 is 9.
Sir, 3 log 10 आएगा ना?
हाँ हाँ
हाँ सर, ठीक है.
3 divided by 0.301 into 10, so it is equal to 6 divided by 3.01. तो 3 ये 01 हम निग्लेक्ट कर सकते हैं, so it will be equal to 2 generations per hour is equal to 2 generations per hour. But this
Sir,
is
per hour.
हाँ per hour. But we are using this 10 hours as incubation time. ये डिनोमिनेटर में 10 hours लिखा है ना हमने, तो वो यूनिट वहां पर जाएगा. So therefore the answer is the value of k is 2 generations per hour. But we are not interested in finding out the this constant. We want to find out the generation time. The equation for generation time is g is equal to 1 upon k. So it is 1 upon 2 generations per hour. So 1 divided by कितना होता है? 1 divided by 2. 0.5.
0.5.
Yes, 0.5 hours per generation, or 30 minutes. 30 minutes per generation. This is the generation time. So there is difference between G and K. They are inversely proportional to each other, or they are reciprocal of each other. Rather than saying inversely proportional, we can say they are reciprocal to each other. So besides this formula, we can also find out the mean generation time by plotting a semi-logarithmic plot. Okay, so semi-logarithmic plot means what? That there is a graph. Okay, that graph has this semi-log scale. 0.10 is the first value. Then it has 0.50. Then the distance decreases, but the scale increases. So it is 1. After that, there is 2 and 3 and so on. तो स्केल जो रहता है ना वो उसका अलग ही रहता है. जैसे हम जो नॉर्मल ग्राफ पेपर रहता है ना अपना, जिसमें एक एक सेंटीमीटर के लाइंस रहते हैं, मेजर लाइंस, लेकिन इसमें थोड़ा अलग ही रहता है. सो दैट पेपर इज कॉल्ड एज सेमीलॉग पेपर. तो उस पर अगर आप प्लॉट करोगे द नंबर ऑफ बैक्टीरिया, you will get this type of graph. Okay, so what is generation time? Generation time is the doubling time. So how much time it takes to double from 0.50 to 1.00? तो ये जो टाइम रहता है, this is nothing but the generation time. So this is your generation time. Okay, so we can use this particular graph also for finding out the generation time. And different microorganisms have different generation time. जैसे कि आपको पता है E. coli. So E. coli has a generation time of 20 minutes. So if we see the examples of different bacteria, you will find that different bacteria have different generation time, and it may range from 10 minutes to several hours. In case of eukaryotes, this generation time is very large. So just for example, the generation time of E. coli is 0.35 hours. यहाँ पे hours 35 doesn't mean 35 minutes. एक आवर कितने मिनट्स का रहता है? 60 मिनट्स का रहता है. ओके, सो 0.1 hour is equal to 6 minutes, and 0.2 hours is equal to 12 minutes. So around 20 minutes is the generation time for E. coli, which is equal to 0.35 hours. और वही आपने अगर एनाबेना का एग्जांपल लिया, एनाबेना हैज द जनरेशन टाइम ऑफ 10.6 hours. 10.6 hours. अगर आपने अल्गी का एग्जांपल लिया अल्गी, फॉर एग्जांपल यूग्लिना, the euglena has the generation time of 10.9 hours. ओके, देन सिराशियम नाम का एक अल्गी है, उसका जनरेशन टाइम है 82.8 आवर्स. ओके, फंजाई में अगर आपने सैकेरोमाइसिस सेरेवाइसी, इट हैज जनरेशन टाइम ऑफ 2 आवर्स. सो different organisms have different generation time, and again this generation time varies with temperature. अगर organism को optimum temperature मिला, then it will show you the lowest generation time. लेकिन अगर उससे optimum temperature नहीं मिला, if it is far away from the optimum temperature, then the generation time will decrease. Okay, so today we discussed about some mathematics related to the growth of organism, and in that mathematics we specifically discussed about the generation time, that is G, how we can find out this value G. And to find out this value, we derived the K, which is nothing but the mean growth rate constant. and with the help of k we can find out the g. But for finding out the value of k, we need the nt and n0 value. Nt is the total number of bacteria after incubation, and n0 is the initial number of bacteria. Okay, so agar nt is related with the number of generation, तो एक generation हुआ तो bacterial number will get double. The generation number is denoted by small n. So we derived a formula, nt is equal to n0 into 2 raised to n. Then we applied the log to both the sides and we solved it for n, that is the number of generations. So small n is equal to log of nt minus log of n0 divided by log of 2. And then for growth constant, which is equal to number of generation per unit time or divided by t, we substituted the value of n into the equation for the growth rate constant, and we got the equation for k, which is log of nt minus log of n0 divided by 0.301 into g. And then we discussed about the mean generation time, which is if it is denoted by, if the t is the mean generation time, then we can substitute the equation, or we can have the equation that is nt is equal to 2 into n0, where nt is the total number of cells after incubation time t. But since t is the generation time, the total number of organisms will be double than the initial number of organisms. Therefore, nt is equal to 2 into n0. And then we substituted the value of nt into the equation for k, and we got this new equation, that is k is equal to log of 2 into n0 divided by, sorry, minus log of n0 divided by 0.301 into g. And then solving this equation for k, we got the relation between the growth rate constant and generation time, that they are reciprocal to each other. So growth k is equal to 1 upon g, or g is equal to 1 upon k. Then we solved one problem where the initial number of cell is 10 raised to 3, which is changed to 10 raised to 9 after time interval t, or after the 10 hours. So we had three values, n0 that is 10 raised to 3, nt 10 raised to 9, and t is equal to 10 hours. So we substituted it in the equation for growth rate constant, and we got the growth rate constant as 2 generations per hour. And then from this growth rate constant, we calculated the generation time, which is reciprocal of the this k value. So g is equal to 1 upon k, or 1 upon 2. So g is equal to 0.5 hours per generation, or 30 minutes per generation. Okay. Have you understood all this?
Yes, sir.
Sir.
Yes, sir.
Okay, so thank you very much. 47 students are present, others are absent. I have recorded this video, so I will share it on, if possible, I will share it on your WhatsApp group and you can just see it. Okay, thank you very much. Have a good day.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir. Bye,
Bye.
sir.
Bye.
Thank you, sir.
Okay, bye. Thank you very much.
जाएगा? मतलब जाएगा?